This is a big suit so you won't get wet. The top. And on the top, it's a big round leg ball. Like it, Mama? It's disgusting. It's a hot dog sandwich. Why do you want to discuss?
I just want to give them something to do while they're waiting for me. I'm going to mute. right. Good morning. I think you're all muted, so that's kind of a silly thing to say, but really? No chat on the hot dogs? I think you're all muted, but you have the ability to unmute yourselves. So keep it on mute if you prefer. If you want to unmute and like jump in and ask a question, that's totally all okay here. This is for all of us. And I think in particular that we've been remote for 2 weeks and we haven't had any face-to-face interaction. So feel free to like, that's how we're all gonna start today. It's like, we're gonna chat. If you have any questions, let me know. I have some questions from the class log. And you know, I want this time to be your time. So whatever you want to chat about first, we can handle all of those things. And then if you get to a point where you're like, hey, I feel good with that, then we can start going with some material and some examples and all of that. Sound good? Physical thumbs up, emoji thumbs up. Hey, it's like, I haven't seen real people in a long time. This is enjoyable for me. Even though we're not in person together, seeing faces in a classroom is pretty nice. Okay, so how about first, I ask for any pressing questions that you have right now. And then if you don't have any pressing questions right now, I can jump to, there were 1 or 2 questions in our course log, and I can maybe say something about that. You doing okay so far? There we go. It's saying that the host muted everyone. Okay, I thought I gave you the ability to unmute yourself. But let's see what I can do. No, that doesn't seem right. Participants, let's click on you. When I try to unmute myself, it says that the host does not allow for participants to unmute. Ah, okay. Well, then I have the power to fix that probably. Oh, there we go. Try now. Can you unmute yourself
better.
now?
That's better.
Yes.
Awesome.
Okay. We got it. Awesome. So you can now unmute yourselves if you would like to ask a question.
How are you doing today?
I am doing well. How about yourself?
Hanging in there. It's nice outside.
Yeah. You all excited? You have other classes that are going to meet in person today, and you're like, yes, normalcy.
I was able to schedule it so this is my only class today.
Oh, man.
Get up at 8 for no other reason.
But at least when it's done, you have the rest of the day to sleep.
I think that is the plan.
Other general questions for right now.
You said it was your daughter who was sick?
Yeah,
Wasn't feeling well?
she's fine.
Is she doing okay?
Yeah, she's
okay.
doing fine. She went back to school like 2 weeks ago, and they're in person. And after 4 days, they sent her home because she had a runny nose and she complained that her throat hurt. And theoretically, that's 2 COVID symptoms. And so it was right of the school to send her home. I'm okay with this. But they have a really long period of time before they will allow her back. So she's feeling fine. And because this was their first theoretical COVID case, although she's been tested and we're waiting results, I don't think she has it, but you never know, right? So she's at home and I'm here so that I don't infect you all. Theoretically, as soon as we get that negative result, she can go back. And I don't know when that negative result will come in, so I'm hoping we all can be together Wednesday. We can at least be synchronous because it's my oldest daughter that is out and she is 8, and so she is capable of leaving me alone for an hour. So we can do this. So I'll stay in touch by email about if we're going to be in person on Wednesday, like in our physical classroom space all together, or if we'll be doing this again on Wednesday.
All right.
That
Where
was
is our
probably the
classroom
biggest
on
question I think that a lot of people had is like, what is going to happen moving forward? Like, how are we going to handle everything? So I'll let you continue with your question if you had more of your question before I just skyrocket into my own tangent. Otherwise, I can try my best to address that.
No, I was just gonna say, like, I hope she's okay, and I hope your family's okay as well.
Thank you. I appreciate that. Yeah, she's feeling great. So even if she does have COVID, she's feeling great, and that's the best part. And we have her homes and all of us home so that we're not hopefully infecting other people, just ourselves. So.
Do you know where our class is going to be when we're in person?
Yes, it's in the Straz Center in room 255.
Thank you.
That's on the second floor. It's right next to the math lab, kind of in the middle.
Thank you.
Other questions, quick? Yeah, I mean, I think that was one of the biggest questions. So one question I'll just start talking about at this point is that somebody said, like, what is this class going to look like moving forward? And I feel like I can answer that better in person than I can typing online. So the first 2 weeks we were asynchronous because my little one was home with me and he's 2 and he like, no way. He'll be like climbing all over me and screaming at this, like it's synchronous is not gonna happen. He is luckily back to daycare today, so we can do this. My hope is that anytime we need to be apart, we can do this because I feel like this is a little better than entirely asynchronous, just watching YouTube videos and learning on your own. Although I guess that's yet to be seen. We haven't done a whole lot yet, other than just like have faces to talk to, which I'm excited about. My hope is that the plan here, right? I tried to design this so that if any of us needs to be apart for whatever reason, it's no big deal. Because if you're sick or if you're stressed or if you have things going on, if I'm sick or if somebody in my household was exposed and I need to be away, I want us to be able to make this work without everything just falling apart. And so in that sense, I will typically do bare bones of the content as YouTube videos for the entire semester. That way, the lecture is online, you can watch it whenever you need to watch it and wherever you are, and we won't be slowed down by if somebody needs to stay home or cancel or whatever in terms of covering the bare bones of the content. However, I think that math is best done through practice. You can watch me explain to you about geometric series and the sum of that series all you want in a YouTube video. For the most part, you'll be like, yeah, I sort of get that, but that doesn't help me do my homework. And so what I think will be best for our interactions, if they're face-to-face in the classroom or in this setting, is for us to answer a lot of questions and do a lot of examples so that we get practice with the types of things that we're going to be expected to do. So that's my plan for this. My plan is we will always have a couple of videos to watch before the next class that cover the content that I would want you to get. And then as soon as we're all together, I'll be like, hey, do you have any questions on that? Was there anything that was confusing? Do you want me to go over anything? And then we can work some examples that are similar to like your homework to the best of my ability. As you'll see as we go on, there's a slight difference between the written homework and the My Math Lab homework. The My Math Lab homework is meant to be quicker and is meant to be kind of like a bare bones, like, can I compute the basics? It's almost like doing flashcards, in my opinion. Like when you're little and you have to learn the times tables and you just do flashcards. I don't know if that's a thing you did. It's a thing I did. Just get good at the basics of it and get going so that you're fast. So that when we have to do big theoretical things, you're not caught up on the little details. And then I think of the written work as more like the bigger picture. The written work will be more like the exams. And in fact, whenever possible, when I do examples in class and when I do written work, they're frequently previous exam questions so that you truly have an idea of the flavor of what that assessment is going to look like. In terms of quizzes, that one's a little bit stranger. Like, what will quizzes be like? Mostly, I think what quizzes will be like, what I'm going to try and do is little Google form quizzes on the content of the videos, just to make sure I feel like if you watch the video, hopefully you can answer the Google form questions, like those were the big takeaways from the video. So I think that's the plan. Before each class, watch a video or two. Answer a Google form quiz to make sure that you got the big picture. Then when we're all together, ask questions and do examples, examples, examples. That's the dream. I don't know what COVID's ever gonna throw at us. Like, I can't predict tomorrow, ever. Like, that's what 2020 has taught me. So that's the dream. That's what we're gonna shoot for. But we will change if necessary, if 2020 throws us like dramatic curveballs, as it has been known to do. Does that help? Yay. Okay, that was the big question. One of the other questions was, can we do examples of limits? And I'm happy to do some more examples of limits. That's exactly the kind of thing we do here, right? Oh, I watched the limit videos. I didn't feel great about it. Can we do more examples? Yes, absolutely. We can do more examples. We could start there. But I want to ask if you just have any other questions about like life and the universe and everything, because that's the big picture stuff. Are you recording this meeting? Yes, I am recording this meeting, and so I can put it online for us afterwards. Other questions, like the universe and everything. Doing okay? How about one other thing that we maybe can talk about, it doesn't have to be today, is like what's going on with the course log? Like, what is the course log really meant to be? At the very least, what I like about having a course log is I want to have a place for you to ask questions. So if like, I think every day in the course log should be a section that's like questions for class on whatever date. So if you're watching the videos, you're doing the My Math Lab, you're taking the quiz, and like something is bothering you, and you're like, I want to make sure we talk about that next time we're together. If you just add a question to that, then I'll know what I should address immediately when we get here. And of course, you're always free to like chime in and ask a question in the chat or unmute yourselves now that you can and just ask. But if there's a thing that you definitely want me to go over and you put it in that document, then I can take a look at it and say, oh yeah, I need to make sure that we cover that. So it's a good way to check in with me. I think it's just another way to check in and like interact with one another. So if you can answer each other on there. If somebody asks a question and you know the answer, then you can do that and you can help each other out in that way. Because as much as we can all see each other and I'm like, yay, people, I haven't talked to adults in a really long time. That's exciting for me. It's not quite the same as like a collaborative work environment. So we'll practice more with that a little bit later on, but let's at least keep it for a question log at this point. I'll answer your questions if you want me to, but I'll also give you the opportunity to answer each other because that can be useful as well. All right, let's go one more minute. Questions, comments, concerns, or are you like, no, I feel awesome and I'm like totally in the mood for lots of calculus? I like that. Yeah, somebody was like, yes, I am in the mood for calculus.
I'm in the mood for calculus.
Yay!
I'll put that up.
Me too. Okay. Awesome. Then remember, you can chime in with questions at any time. If something comes up about life, the universe, and everything later on, and you really want to ask that later, feel free. This is your space. But if you're ready for some calculus, let's do some calculus. So I put a document up on Schoology. If you go to the week of September 14th, there is a worksheet in there now of things we're going to do. And if you'd like, I can pull it up on my screen and share my screen with you, but you also have the ability to access that document in Schoology. There we go. Do you want me to put it on my screen so you can see it? Is that easier? Yes, okay, cool. I can do that. So this is the worksheet we're looking at. Because it was requested in the course document, in the course log, I started out with some limits that we could do as a warm-up. So all limits at infinity at this point, but I gave you 3 different functions you could take a look at. I think those are the things that we should do first. And we can talk about them as a group. I can give you some time to work on them on your own if you'd like. And then if we feel good about limits after this point, then we can go on and do some other examples that are like the video that we watched for today. How do I see you at the same time? There we are. So here's what I'll do. I'll give you some time to take a look at those limits and either find some answers or come up with some questions that you're like, yeah, that's what it is about limits that was really bothering me. I don't understand how to do blah. I'll give you a couple minutes. I'll set a timer so that you're not doing this forever and ever. And then we'll figure out how we're going to chat about them. We'll do 1 minute a limit. So I'll set a timer for 3 minutes. Boom, go. Oh, I think I'm sharing that screen. You don't want to see that. There was the timer. Now that was a total random guess. Was that timer enough time or totally not enough time? See a thumbs up, like, cool, I'm doing all right. Couple thumbs up. Okay. It's really okay if it wasn't enough time. It was probably at least enough time to like glance at them and get some thoughts down, right? How do you feel about breakout rooms? Do you want me to try and give you some breakout rooms so you can talk to each other, or do you want to be all together? Kind of like, whatever, let's try the breakout rooms, right? Let me get back to a Zoom setting where I feel happy about life. Oh, okay, don't do that then. Let's make some breakout rooms and let you chat. So take my participants and put about 3 people in a room. Create the rooms, that sounds great. Open them. There you go. Let's take a couple minutes, chat with each other, check your answers, come up with some questions, and then we'll all come back in a little bit. Yay, some of you are back.
Yeah.
Does it count down in your breakout room?
It will count down, but you can click a button to say join the other room early.
Yeah, I knew you could get out early if you wanted to get out early, but I didn't know if it would give you a countdown. So I felt like I had to give you this 1 minute warning, and it seems like that was totally unnecessary, that like Zoom would do that for me.
Yep.
We'll get it all worked out. I think you're all back to me now. Yay, okay, cool. How did those 3 go? They're of sort of 3 different flavors, and so any one of them we could chat about as a large group if you have some questions. And we have a couple different mechanisms for like how we can work with one another, right? So one thing that I think could be helpful, I did ask you in an email a long time ago to get yourselves a whiteboard. Because when we're in the classroom together, if we're supposed to be working with one another but not getting close to one another, I think we're going to need to like write on a thing that's big that we can like hold up and show one another. So that could work when we're Zooming as well as like a nice low tech solution. I also have a whiteboard. There's a slight complication. Let's see if it does it or if I fixed my setting. If I hold this up to you, oh, I fixed it. That reads correctly, yes?
Yes, it does.
That's a setting though in Zoom. Your camera will automatically mirror, and so if you don't change it to not mirror, the writing will be backwards for your group mates. So you'll want to check that setting. And frequently you actually do want the mirror on, but for handwriting on your whiteboard, you're not going to want that. I know in Zoom you can use the whiteboard as well, but my handwriting on that is so terrible. I think a literal whiteboard is better for me for writing math than other things. So this was my answer for the first one. Did you feel good about the first one? I felt like the first one was one that hopefully we should feel good about. That's like a My Math Labby type thing. And that exact problem that I gave you all to work on is a quiz question that I would give in a past thing.
Can you hold it up again?
Here we go. So if we feel good about that one, we could move on to the middle one. The middle one was maybe like medium difficulty, and that one came off of an exam that I've given previously. How do you feel about that g of x with the natural log in there?
Can we go through number 2 as a whole?
Yeah, absolutely. So I didn't write it on my whiteboard. Another thing that I did with number 2 is if I share my screen again, over here, and then I click through here, I typed it, because math can be typed real pretty. So I typed my answers for these, which is the benefit of knowing what questions we're going to have in advance, is that I can type answers to them and they can look all nice. Oh, Zoom just beeped at me, did a thing. Who's here? Who got kicked out? Yes, you can come in. I don't know. It beeped at me, but I'm not really sure why it beeped at me. Okay. Sorry if I'm ignoring you. Go away. Anywho. Right. So the natural log frightens us, right? Natural log, we're like, ugh, I don't like the natural log. So my first keyword is ignore it then. If it's troubling you, just ignore it, right? Focus on the mess that's on the inside. That's a nice rational function. Oh no, it beeped again. Why are you beeping at me? Ah, Sean got kicked out. Come back in, Sean. That's why you're beeping at me. Yay, okay, Sean's back. Welcome back, Sean. Okay, so we're ignoring the natural log because it frightens us, and that's a reasonable thing to do. And we're looking at the rational function that's on the inside. We feel better about that because there's no natural logs, but also like we had a whole set of videos on rational functions. So we're like there, I feel like maybe I at least know like where to go for a resource to look up some ideas. I'm superimposing my thoughts on you. You can yell at me and correct me if I'm wrong. I'm just guessing, right? But okay, when I have a rational function, which is polynomial divided by polynomial, the game is look for the biggest power. Look for the biggest, baddest thug in the numerator, look for the biggest, baddest thug in the denominator, and just focus on those two pieces and throw everything else away. That's rate of growth. That's what we want to do all the time. Find the biggest and the baddest and the meanest and the fastest and grab that one. So for us in the numerator, that's the x cubed. X cubed is doing all the work there. As x is getting really, really big, how big is 10 cubed compared to 10? The 10 doesn't do any of the work, right? The 1 doesn't do any of the work, right? So why bother? So focus on the x cubed in the numerator, focus on the ex cubed in the denominator. And if I were then to throw away everything else that's in the top and the bottom of the fraction, I get a really nice, beautiful limit. Like, cool, the x cubes canceled. That's just a 1 over e, the ratio of the coefficients. Huzzah. Okay, cool. So if I then like take the pin out of the natural log and I'm like, oh, I have to remember about the natural log, that's
Are you
okay.
sharing a screen right now?
Sorry, what's up?
I said, are you sharing that screen with the
Oh, I
natural
thought
log?
I was. Oh, damn it. I'm not. That's why. Sorry. Excuse me. Now can you see it? Now it says your screen is sharing.
Yeah.
It's the 2 clicks, dude. It gets me every time. Like, it says share it, and I select the screen, and I think it's going to happen, but after I select it, I have to hit share again, and like, I can't remember to do it. That's my mistake. So let me give you a minute then to look at it and see if now you can like catch up to all the words that I was saying, because I could see it. Not cool. So this is all I was saying. Ignore the natural log. Just look at that inside. Then ignore this stuff. Ignore that stuff too. And then the whole problem is like, yay, this is way nicer. Then when we're focused on this limit, once we put the natural log back in, but we replace the inside with the really nice thing that it has the same limit as, it's not equal to that. That big nasty fraction of polynomials is not equal to 1 over e. It has the same limit at infinity as 1 over e. Then this becomes a lot nicer. Don't need my limit sign anymore after this stage. And then we get into this nonsense over here, okay? Oh, that's not really necessary. And in fact, I don't know why, I must have just decided to crap out. Natural log of e is 1, so this should be -1 as your answer, if you really want it. Let's see, on an exam, if you got to here, where you have natural log of 1 over e as your answer, I'd give you full credit for that. You don't have to do this stuff. But it's a thing that we remember, that there are log rules sometimes. Sometimes we use them, most of the time, no. Does that help with this one? Do you feel okay about this one? Awesome. Okay, how about the next one? How about this one? The x minus cosine squared of x over x cubed? How about that one?
Can we go over that one, please?
Yeah, absolutely. Does anyone have any thoughts you want to pitch in about it? Like, what's the part that frightens you? Because often there's like, I think it's cool that maybe frightened is not the right word, but like, what's the part that troubles you or that is weirder? I mean, for me, it's the trig function, right? You see a trig function, there's a little bit of panic. It's like, I don't really know how to deal with that, especially with end behavior, and especially because I didn't put that in the video. I know I didn't put it in the video, so that's fair. Chat. I don't want to show me multiple things at the same time. Alas, okay. Anyone want to unmute and comment on it, or do you want me to walk through it?
Yeah.
I'll take it. Thank you, Georgia.
So, I think it could be 0 because the higher power is in the denominator.
Mm-hmm.
We were a little bit wondering if this is infinity over infinity case, but actually if you put in infinity to cosine squared, that's probably, that doesn't have a limit because it's periodical. I don't remember the term. So yeah, my thought maybe 0.
Awesome. How many votes for 0? How many votes? You could raise a hand, you could give a thumbs up, give a smiley face. Lots of votes for 0. So you don't need me as much as you say you need me. 0 is absolutely correct, right? 0 is correct. That is that limit. You have everything that Georgia said and that her group discussed is all correct. And in fact, Georgia, I'm so glad that you handled that because you brought up a thing that I haven't even mentioned this whole time, which is this is an infinity over infinity limit. This is an indeterminate form, exactly right. So I've been doing all of these with rate of growth, but I haven't even mentioned L'Hopital's rule, but that's a good rule and we can use that as well. So if you were doing L'Hopital's rule for 1 and 2 and getting answers that way, that's a perfectly valid method of approaching these problems. I tend to go more towards the rate of growth method because I consider myself something of a lazy mathematician. And if I use rate of growth, I can just be like, it has the same limit as this other thing because rate of growth, and I don't have to do multiple computations with L'Hopital's rule. But L'Hopital's rule is perfectly valid on any of these. I'm not 100% positive it'll help you with the third one, which could be another source of trouble, as if you were trying to use L'Hopital's rule. I'm not sure it's going to be very helpful on the third example. But everything you were saying is absolutely correct. The rate of growth of the denominator is stronger than the rate of growth of the numerator because although the cosine function and thus the cosine squared function is a periodic function, it doesn't have a limit at infinity. That limit does not exist. It is bounded. It's not very big. Cosine squared will always be a number between 0 and 1. You could plug in cosine squared of 500 billion and it will be a number between 0 and 1. But x will be 500 billion. So the idea is, if you want to approach this from a rate of growth standpoint, that cosine squared, it frightens me and it doesn't have a limit at infinity, but it's small. It's in fact smaller than 1 all the time. And so if we're talking rate of growth and like how big is the numerator compared to how big is the denominator, the cosine squared is entirely irrelevant. It doesn't do anything to affect how big the numerator is. So for all intents and purposes, this problem might as well be the limit as x approaches infinity of x over x cubed. And then we reason correctly either with canceling an x from the numerator or doing a L'Hopital's rule or whatever you want to do, you're going to get a limit as x goes to infinity of 1 over x squared, and that limit is 0. So your intuition was all right there. Did anyone try L'Hopital's rule on this? I'm too lazy to do it 3 times. Probably only once. You probably get a limit after one application. Oh yeah, go ahead. Nat?
Yeah, I did, and then I got 0, and then I second guessed myself.
That's okay.
So, I have a question. Can we go over like limits with trig functions, like just trig functions? Is that okay?
Yes. Like limits at infinity, limits at specific points, limits of ratios of them.
At infinity.
At infinity, yes.
At infinity, yeah.
Most of them do, all of them do not have a limit as x approaches infinity or negative infinity because they're periodic.
Yeah, that's what I thought, but I kept.
Yeah, if you're talking about like limits at 0 or limits at other values.
I'm sorry.
Oh no, you're totally fine. You're all good. Yeah, none of the trig functions will have a limit as x is going off towards infinity. None of the 6 standard trigonometric functions will have a limit as x goes to infinity. If we wanted to get really terrifying, we could talk about inverse trig functions, which do have limits at infinity, some of them. But let's put a pin in that for now, shall we? There was some head shaking. Let's not go there today. Not today. 8 a.m. Different time. And we won't need that yet, so it's fine to ignore that for now. Other questions on limits or other things related to it? Because I didn't do a L'Hopital's rule example here. I handled all of these with rate of growth. So if there was anything L'Hopital's you wanted to discuss, we could do that now too.
I have a question from my math lab assignment.
Sure.
And it's more so the algebra that I can't get than the calculus, but the problem was, just a sec, I have it. It was the limit as x approaches infinity of x over 10 times tangent of 10 over x, and that's like a 0 times infinity case where you need to make a fraction, but
Can I write it so that I make sure I have your limit? Can you say it one more time?
so the limit as x approaches infinity of x over 10 times the tangent of 10 over x.
Oh. A tangent of 10 over x?
Yep.
Interesting. Over x, and there's an x in the numerator. So I have my pretty board. Do I have it correct?
No.
Nope.
Maybe. No. I think it's x over 10 and then it's times. So it's x over 10, that's one term.
Huh?
Times the tangent of 10 over x.
Times the tangent of 10 over x. Gotcha. Okay, let me fix it. And then you'll tell me if it's correct. That look right?
Yeah, that's it.
Okay. Yes. So my first thoughts on this limit, my first thought is to make myself a fraction. Right? This should be approaching, this is a different kind of indeterminate form, which is why this is nasty. So let me write the first line. The tangent of anything is the sine of that thing divided by the cosine of that thing. So my thought is that if I break tangent up as a sine over a cosine, this will at the very least put this into a form where I can use L'Hopital's rule if I have an indeterminate form. So that would be my first hope. So I'll hold this up for you all again. Did what I say out loud make sense? Break up the tangent as a sine over a cosine and see if that gets you to a point of an indeterminate form. I'll write that next so I can show you, and I'll also answer a question from a child. So I'll give you a minute to work and then I'll check back in. Let me mute this thing if I can.
Could you, oh,
All right, I'm back. How are you all feeling? There's a question in the chat. Let me get to the chat. Substitute 10 over x from Jared. 10 tangent of 10 over x. That's not right, yes. your progress here? How's it coming along? Jared had a hint in the chat.
If you do sine of 10 over x over cosine of 10 over x, you get 0 over 1, which is 0. And x over 10 is infinity, or when you substitute the infinity into that, you get infinity times 0. So I think the limit's 0.
Well, isn't it that you have to make everything into a fraction and then apply L'Hopital's rule? Is 0 times infinity allowed? I thought that was also indeterminate.
What do you all think? I never want to chime in and steal your thunder. So if other people have things to share, I'll let you share before I jump in. So this is strange. I thought I went through this. For me, as I'm looking at it, it doesn't quite seem like, I thought I would not have assigned a problem like this, but I guess I did. So now we have to handle it, right? We have to go over it since it was there. Infinity times 0 is actually an indeterminate form still, because I think of 0 like a very small number, like a 1 over a billion, right? So if I have infinity, which is a big number, times 1 over a big number for my 0, that's kind of like an infinity over an infinity, which is an indeterminate form. It's just a way of dressing it up, so it doesn't look like infinity over infinity. So if we do want to do a L'Hopital's rule here, we need to make it look like an infinity over an infinity. What I'm not seeing here, even with the substitution, so I took Jared's advice too, even when I write it, oh, this is hard because then I can't see the thing, but you can see, right? Even when I put sines and cosines there, it doesn't get me an indeterminate form the way I want it to. I think Jared is right. I like the substitution of taking 10 over x and making that a new variable. So actually I have a typo. This is a u. Let me fix it. I can see that. Oh. I like that substitution, but I am not quite at indeterminate form yet, because I still have an infinity times a 0 in the numerator and a constant in the denominator, as Sean pointed out. Sean pointed out if I change it to sine over cosine, I get a number in the denominator, and that's a really good thing, which it generally is. Okay. Jared's chiming in. Jared, do you want to show, do you have a board to show us, or do you want to unmute and like talk us through your solution? Because I think you've got good thoughts going on here.
I have a piece of paper at the moment.
That'll work.
Yeah, I substituted with H, but hopefully you'll be able to see it because I can't see my own paper. I can't see my own face. So the idea is.
Yeah, I can't see it. I think you got to move it to like block your face. That's the hard part I was just having. I'm like, I can't see what you see if I.
I'll just try explaining it.
Okay.
Okay, so yeah, you substitute 10 over x, and then instead of splitting it into sine and cosine, you just keep it as tangent and move and multiply it in to get tangent of it, to get the limit of x, the limit as x approaches infinity of tangent h over h. And then you have an indeterminate.
There should be a 10 somewhere. Okay. So let me see if I wrote, I might have lost a 10 somewhere, but this is approximately what you had, Jared?
Yeah, I just forgot to switch the variables and under the limit, so yeah.
Mm-hmm. Right, I might have a 10 missing somewhere, but I think this is the gist of what happens if you make that substitution, that u should be 10 over x. And if that's true, then we're happy because we have a 0 over 0 indeterminate form, and we can apply L'Hopital's rule to that. So here's what I can do. I can try to write out, if you'd like, exactly how we get there. So our original limit was x over 10 times the tangent of 10 over x. So x divided by 10 is 1 over u. That's the substitution of variables that leads to that new limit where L'Hopital's rule can be applied. And then once we're in that situation, tangent of u over u, we can apply L'Hopital's. What's our derivative of our tangent function?
Secant squared.
Secant squared. What's the derivative of u?
1.
1. So then we'd be looking at a limit as u is approaching 0 of the secant squared. Now, if you're like me, I don't know what that is off the top of my head, right? I do trig, and we'll review trig one day, just trig when we do inverse trig. I remember sine and cosine limits, and that's all I can keep in my head because it's too much otherwise, right? So I know that the secant is 1 over the cosine. And so I can figure out what that limit of the secant is by thinking, well, I actually know the limit as x approaches 0 of the cosine of x. I know that that should be 1. So if the secant is 1 over the cosine, then I can get a 1 over 1 here. So this limit should be 1. I believe. Is that what everybody else gets? That's my trick. For all trigonometry, I'm going to tell you, like, I don't know what that is, but what is that in terms of sine and cosine?
Is
I
the
can only
limit
hold so much. What's up, Sean?
is the limit approaching infinity or 0?
I think our original limit approaches infinity. And then what I did was a change of variables, and I let u be 10 over x. So as x is approaching infinity, u is approaching 0. So our original limit is an infinity limit, and then when we make a change of variable, our limit now approaches 0. X is approaching infinity, u is approaching 0. I think that's a mistake. I think that I didn't mean to include that problem. So I'm happy we went through it because there's good math there, but I don't think that that was meant to be a main takeaway of the L'Hopital's rule section. And so if you're like, I feel like this blindsided me and where was I supposed to have gone in the videos for this? That would be like a reasonable thing to think on that example.
Yeah, I got screwed up by the second part of that question, which is like another version, something involving, I think my exact one was 8e or 8 plus 9e to the 9x over 9 plus 8e to the 8x. That really got me.
The one thing I will say is I hope that you've been playing around with my math lab. It has helper things. So this does happen from time to time. I'm recycling old homework assignments and I try to go through them and remove things that are no longer applicable. But every now and again this happens where you get a problem that includes some sort of problem that I like focused on the year before, but didn't really focus on this time around. And so the problem seems weird and you're like, I don't know how to do this. But my math lab does have helps. Like you can click like walk me through it or show me an example or point me to the textbook. And those things can be helpful when you feel like you're blindsided by something. And also then just letting me know and we can have this discussion where I say like, I'm glad we were able to do that, but that one like, don't feel too bad. If you were blindsided, that's just a mistake. Then that conversation is helpful as well.
Oh yeah, those helpers carried me.
Mm-hmm. Other questions or comments on limits or other things that you want to discuss?
This happened like more in the sequences my math lab. I was a little confused, so I used the helper, like the view an example. It was talking about a sandwich theorem for sequences. Can we go over that? Because I didn't really.
Yeah, actually, I think that's like a perfect way to end up completing our discussion today, because that's another thing I could have done with one of the limits we did earlier, is done a sandwich theorem. So I don't express it. And another thing too is that there will be a difference between like what the book tells you to do and what I might do in class. I know that that can be frustrating because it might be pointing you to do something one way, and it's frustrating that I'm not doing the same thing. For me, I've always viewed that as a bit of a strength, because if the things I'm saying to you like aren't coming through, if my method of approaching a problem just doesn't work for you, I think it's a good thing that the book does it a little differently, because if that's something that resonates with you a little bit more, then you have an alternate viewpoint. It's not like where somebody's doing Pictionary and just pointing at the same thing over and over again, and you're like, we don't get it, dude, move on. Like, you have a different approach to it. But I do know that that can be frustrating when you're like, she never did it this way. I don't know what I'm supposed to do here. So for example, the third limit that we did, that g of x function, x minus cosine squared of x over x cubed, I can share my screen again if you want to see here, and I'll actually share it this time so you can see it. This limit. I approached this problem with an end behavior model type philosophy. I'm just going to throw away that cosine squared because it bothers me and its size is not important. In some sense, what I'm doing there is a lazier approach, and you could approach it with a sandwich theorem instead. So you remember the sandwich theorem? It has my favorite thing, which is like a great visual. I don't know, I could Google it and see if I could get a picture real quick, but I could also do it with my hands. The idea is you have some sort of function. So you're ready for my function with my crazy hands? This is the function. It's weird. I don't like it. It's messy and it's nasty and it's ugly. Most of the time it does this. Wobble, 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 wobble. Okay? That's the standard sandwich theorem type thing. And so the idea is what we're going to do is we're going to put a nice function below it and a nice function above it. And now I need a third hand and I don't have it. But you can imagine putting a nice function here and a nice function here. They're nice because they're so easy and they're pretty. And what they want to do is like converge to something, and they want to trap the wobbly, shaky crap in between it. And there are pictures, and we think of it as sandwiching because the two nice things are like the bread, and then you've got the crazy function on the inside. So what I could have done with the example that's on the screen, maybe I could change it really quickly. Let's go to Mathematica for this. I can share my screen and do some Mathematica, and maybe that will help us here to get some pretty visuals in a short amount of time. And then we can end here. I had a function, and don't worry too much about the notation here. At some point we will go through Mathematica and we will talk about how to do all of this nonsense. But here's a function, and it was x minus cosine of x times cosine of x. That was my numerator divided by x cubed. That was my function. Let's ask Mathematica to plot for me three things as x goes from like 0 to 10. Let's go 1 to 10, okay? Let's have it plot the function x over x cubed. And let's have it plot the function x minus 1, that quantity over x cubed. One of those functions I can't see. There should be 3 functions here. Because I didn't put f of x in there. There we go. That's why there's only 2 functions. And then let's see here. I think that that's kind of unhelpful because I see 3 functions, but I don't even know which function is which. So let's ask Mathematica to maybe give me a legend. There we go. That's much better. So the blue function, that's x over x cubed. The orange function is my function, f of x, and like, look at the wobbly. Look at the wobbly. And the bottom function is x minus 1 over x cubed. Let's maybe go to like 6 here instead. That gives me a better picture. This is a perfect sandwich theorem type thing. Here's nice function number 1. Blue function, x over x cubed. That's a rational function. Rational functions are nice calculus-wise. 1 over x squared, that's not bad. X minus 1 over x cubed, that's also a rational function. There's at least no trig in it, and that makes me happier than functions with trig in it. And look to see that this function is always less than my nasty function. So the sandwich theorem applies when you have a nasty function that you don't want to deal with, and you can come up with 2 nice functions. One that's a little bigger than your function, one that's a little smaller than your function, and both of the nice functions have the same limit. If you can show that that is true of whatever you're looking at, functions, sequences, whatever, then the nasty function has to have the same behavior as the 2 nice functions because it's stuck in between the 2 nice functions and there's nowhere to go. The 2 nice functions have the same limit. The thing that's stuck in between, no matter how nasty, has to have the same limit. So a different approach that I could have taken to that 3rd example I gave you is to use the sandwich theorem and say this function is stuck in between x over x cubed and x minus 1 over x cubed. Both of those functions are rational functions. I know their limits. Both of them have limits of 0. So this other function that's in between, it has to have a limit of 0. Does that make sense? You can use the sandwich theorem if you want. It's totally valid. And I think high school calculus in general focuses on it a lot. So it's a totally cool technique. You're fine to use that. It's just I tend to use end behavior model because then I had to write less. I only had to deal with 1 function. I was like, yes. All right, doing okay? We have 1 minute left of class. I want to make sure I'm respectful of your time so that if you have other places to be or beds to get back to, that you can do that. For Wednesday, the 2 remaining questions that are on this worksheet that I posted on Schoology, let's start there on Wednesday. Hopefully, we'll be back together in person on Wednesday. If not, I'll send you an email before class, the day before, and I'll let you know. But that's where I think we should start. And head to the course log if you have any questions. I've also got 2 more videos that I posted to that Intro to Series YouTube playlist. I think you should watch those and take a quiz on them before Wednesday. But if we don't have time to get to that because we're still working these 2 examples that are on this worksheet number 1, that's okay. And then we'll get caught up after that point in time. I'll put it as a to-do online as well so that it's written down somewhere as well.
Do we have class tomorrow or are we taking the lab day off?
Thank you. That is a good question. We will not always take the lab day off. Tomorrow we will take the lab day off. Because I'm giving you all these videos to watch and I'm making you do that as well as homework outside of class, I think it's only fair to give you some class time to accomplish those things. So tomorrow we will take the lab day off so that you have time to watch those videos, take that quiz, and work on your homework that's due on Wednesday.
Awesome, thank you.
Thank you for telling me that because otherwise you all would have been here and I've been like, what? What class? Yes, take tomorrow off so that you have time to focus on those tasks. Good? All right, well, it was awesome to see you all. Thank you for coming, and we will see you on Wednesday, hopefully in person, if not here. Have a good one.
Day.
Thank you.
Bye.
Have a good one.